All right, so in this one here, we're going to do 12.4, which is just an introduction to polynomials. Oh, this Sunday, chapter 12 and 13, because then your test, yeah, all of chapter 12 and 13. So we started 12 last week, and then we'll finish 12 today. And if we don't, I'll make some videos so you'll have them. Do 13. If I don't finish 13, then I'll make some videos on Thursday so you'll have those as well. And then your test will open up next Monday, and then you'll have a week to do it. Chapter 14 videos will be posted as well, but you'll have 2 weeks to get chapter 14 done. Because my goal is when I come back is answer any questions on chapter 14, and then we get into chapter 15 that week. So if I can do some 14 questions and then go into 15. Right? And then we'll take, I think after that, the following week, that Monday, the 8th, we have our third test. And then I'll do chapter 16, which we don't do all of it. We only do like half of it on Wednesday. And then the following Monday after that will be your final exam. And then we're done. It's fast paced for an 8-week course. Well, I'm taking the kids to the Bahamas. We're going to take a cruise. Yeah. We do Carnival. Yeah. Have more stuff for the kids. Yeah. Royal Caribbean's not kid friendly. Yeah. So. Oh, double the price on a regular cruise. I know. I'd rather just take the kids to Disney versus on a cruise. All right, so 12.4, again, we're just going to be talking about introduction. So we start off by simplifying our polynomials, and then we're going to name these polynomials. So we'll start off kind of slowly and then progressively get harder throughout the section. So on part A, we have 4x squared plus 5x squared. So the first thing you need to understand is when we are simplifying, we want to combine like terms. And combining like terms is finding terms that have a letter, the same letter, with the same exponent. And if they do, like in this case, they both have an x and a square, then all I have to do is add the coefficients in front of those terms. So in this case, what is 4 plus 5? The term itself will remain the same. It does not become x to the fourth. It does not become 2x squared. The term itself will remain the same, and all you do is add the coefficient. Well, so x squared is like an object, right? If you have 4 candy bars over here, and then you got 5 candy bars over here, how many candy bars do I have? 9 candy bars. The candy bar itself did not become a Reese's to a Snickers, right? So it will remain the same thing that it was. So look at x squared as an object. I don't know what the object is, but we'll call that object x squared. So the x squared will still be x squared. We just have 9 of them now. Kind of think of it like that. All right, so let's look at another one. Oh, and then we have to name these guys. So if you have one term is called a monomial. Is the 9x squared. This is called a binomial because it has 2 terms. Right. So terms are separated by pluses and minuses. So this one I have 1, 2. So it started as a binomial, but after I simplified it, it became a 1 term. So this right here is a monomial. But then you also have to tell the degree. Now, I teach kids linear, quadratics, cubics, and all that, but you don't need to know any of that. What they kind of require you to do is just to pay attention to the highest exponent that you have. In this case, it's a 2. So you'll call it a second degree monomial. So it's like a 2-part question. Simplify it and then name it. All right, let's look at some more. So this right here is 4x squared plus 5x squared minus 5x. So before I simplify it, how many terms are there? 3. So if this was to stick, 3 terms is called a trinomial. How many terms you have? Yeah, so in this case, yeah, I'm going to count how many things I have between pluses and minuses. It doesn't have to be x's. They could try to throw you off and put some y's and q's or whatever. Yeah. All right, so what can I combine in this situation? Very good. I have an, do what? Just a 4 and 5, yeah. Yeah, so this right here is, these are Reese's. This would be a Snickers, right? Because it's different. So in this case, I have 4 Reese's and 5 more Reese's. So I have a total of 9 Reese's. And then you kind of ignore the terminology with the minus 5 Snickers because that means you would have eaten them. But I couldn't do anything with this, so it just remains minus 5x. Mm-hmm. Good. So this would be a binomial since it's 2 terms. And what's the highest degree? So it's a second degree. Perfect. So this will become a second degree binomial. All right, let's look at this one. 1/3 y squared plus 4y cubed minus 3y squared plus 8. What could I combine? This one has a third degree. This is a second degree, so I could not combine those. Perfect. I can do the 1/3 and the -3 because those are both y squares. Now, I will also state here, when you are writing it out, it does like it in standard form. Standard form is highest degree to lowest degree. So which one of these is actually going to be my first term? The 3. So this right here would be the first term I want to write because it's the highest degree. So I'm going to write 4y cubed. Now, I didn't have nothing to combine with, so I would leave it there. Now I'm ready to, one more time. So it's called standard form. So I look at the highest degree and I look at the exponent. So 3 is bigger than the 2's. So I know that one's going to be the highest. Because then my next term will be this square or the second degree. So what is 1/3 minus 3? So I'm just going to pull out the coefficients right now so I can kind of look at it. Put this over 1, and then you're right. I have to multiply this by 3, and if I multiply the denominator, I must also multiply the numerator. So then this becomes -9/3. So what's 1/3 minus 9/3? Good. So what happens is we actually do the operation on top. So 1 minus 9 gives me that -8. And then the denominator stays the same. So it becomes -8 thirds. And then write what object you had. So that was a y squared I was dealing with. And then after all that work, don't forget about that lonely +8. It's still part of the answer. So this becomes then 1/3 minus 9 thirds. That's what this becomes. And so in reality, what you're doing is 1 minus 9 over 3. Because you do the operation on top and the denominator would still be the same. So what would be the name of this answer? The trinomial. Good. Third degree trinomial. You look at the highest exponent. That's your degree of that polynomial. So it becomes a third. Mm-hmm. It'll be a 7th degree. Yeah, so we don't really have, it goes first, second, third, then like 4th, 5th, 6th, 7th, 8th. I try this one. 3x cubed plus 4x squared minus 8 minus 3x cubed. They are like terms. That's exactly what they are. So what does that give you? 0. You had 3, I don't know, Kit Kats. So now we got cubes. And then I ate 3 Kit Kats. I don't got no more Kit Kats. So then what will be my answer now? Oh, if they cancel, would I still have an x cubed? You would even write it down, because if you wrote it down, you're still indicating that you still have 1. Mm-hmm. But that is a definitely a misconception there. A lot of students they'll see 3 minus 3, they'll go, oh, that's 0, but then they'll still write the x cubed because like, well, I don't have a number there, but there's an imaginary 1 there. All right, so now what will be left to my answer? Very good. And I couldn't combine those, so how do I name this? Very good. Because there's now 2 terms. 1, 2, separated by either a plus or a minus. Mm-hmm. Try to squeeze another one. So I'm going to try to squeeze another one. So I kind of talking to myself. All right, last one of this type, and then we'll try another one. So -4y to the -3rd plus 2y to the -1 plus 3y squared. Just so you are aware, it does say simplify each of the following polynomials, then state the type of each of the polynomials. So this is not a polynomial. What do you notice about all of the exponents leading up to E? Well, these are all positive, but the ones in E are now negative. So if you end up with a question and the exponents are negative, not a polynomial. Now, we see negative exponents in the previous sections, but what do we learn? What happens to the negative exponent to make it positive? Flip it, it goes to a fraction. That's actually called a rational function, which are not polynomials. So it makes fractions. Polynomials, they might have fractions like coefficients, but them themselves are not fractions. So if you see a negative, super easy answer. Yep. So if you end up with negative exponents, super easy answer, not a polynomial. Can't simplify something that's not a polynomial. All right, let's look at a different kind of question. 2 says simplify the following polynomial, then state the degree and type of polynomial. So it's actually the same question, but a lot longer. There we go. So it's going to be x cubed plus 6x squared minus 5 plus 12x cubed plus 9 minus 8x squared. Simplify. And my recommendation when it comes to simplifying is as you're simplifying it, go ahead and write it in standard form. Look at the highest degree and then just go down from there. So what's your highest degree here? The third degree. So which ones can I combine them? Okay. And what would x cubed plus 12x cubed give me? Very good. There's an imaginary 1 in front of that x. So this becomes 13x cubed. What will be your next degree? And what can I combine there? Oh, you already combined the 12. So you want to do the negative 8. I will say a couple of tricks that I've learned when combining. You'll notice I'll put like kind of different symbols. Some people like to use circles and squares and triangles. I just use lines. Like this single line means I can combine these. 2 lines mean I can combine these. And then it also tells me I've combined those. And because you'll get to a point where there's like 10 of them there, and you're just like, all right, what have I added? What have I not added? And that gets a little taxing. So what is 6x squared minus 8x squared then? All right, and then what else can I combine? So negative 5 plus 9 would give me positive 4. Very good. And then now we need to name this. What would this be called? Third degree. Perfect. Oh, yeah. Well, times 10 to the 0 power, that means there's no decimals or no need to move the decimal. All right. So any questions on simplifying or naming? All right. The next part is evaluating. And it's relatively straightforward if you just plug it into the calculator as well. But what gets a lot of students is they plug in incorrectly. My recommendation when evaluating and you're plugging in a value, use parentheses to separate your numbers. So for instance, on number 3, you are given p of x, that's just the name of the function, equals 3x cubed minus 5x squared minus 13. And it wants you to find p of 3. Evaluating functions. Mm-hmm. Polynomial functions, that's fine too. Yeah, you're good. So the key here is to realize that this 3 that's inside the parentheses here is replacing that x. And if it's replacing that x, it's going to replace all the x's. So P of 3, if I'm going to substitute, I'm only replacing the x. So I have a 3 that's already part of the formula or the function. So I'm going to write the 3. Then I come up on the x. Well, the x is now going to become a 3. But if I just write a 3, that's going to look like 33. So I'm going to use parentheses and then plug in what that value of x actually is. Now, what this does, it does 2 things. One, it separates the numbers so it doesn't look like 33. But 2, parentheses indicates multiplication. So then I know I'm multiplying this result. And then I have a cube. So that's going to stay there, or a 3rd degree, minus 5. I see an x, so I'm going to replace it with the parentheses 3, square or 2nd degree, minus 13. So basically, I rewrote the function. Just anywhere there was an x, I replaced it with whatever value it told me. Now, you can do this in one of 2 ways. You can evaluate this by hand, or you can just plug into the calculator and get the answer. I'm good either way. If you're a by hand person, I'm good with that as well. But PEMDAS tells us to do parentheses, but there's nothing inside parentheses to do. And so I do exponents next. So I would need to do 3 cubed first. Which is 27. Minus 5. And then I would need to do 3 squared, which is 9. And then PEMDAS then tells me I can multiply. So 3 times 27, 81, minus 5 times 9, 45, minus 13. So then I would say, all right, what's 81 minus 45? 36 minus 13. So again, you can plug it all at the very beginning and get 23. I'm good there. Or go through the process, and I'm also happy to. You type it just like you see it. You see a parentheses, you write, you type a parentheses. You see an exponent, you type an exponent. You type it just like you see it. You could do it that way as well. You can plug it in at this stage, or you can plug it in at this stage. Regardless of what stage, you'd get 23 each time. No, that's good. Oh, this was the question. It says find P of 3. So basically what that's telling me is when I substitute all of this in, P of 3 is equal to 23. So basically what this is stating is if X is 3, my answer ends up being 23. Perfect. Oh, it was given to me. That was part of the question. I did not come up with that. The question was find P of 3. I didn't just pull it out of thin air. That was the question. That's a good one. No, it's not always a 3. It's whatever they ask. Correct. Instead of the X, and then you work your math out. Yeah, that part will be given to you. So all in black was given to you on the test, on the homework, and in the blue is what you worked out. Yeah. Basically, you just plug in the 3 and that's it. Whatever number. Yeah. So let's do another one. Let's look at number 4. So let's say we get P of Y, because they're going to try to change letters, but it's the same process. Let's say it's 4y cubed plus 2y squared minus 8y plus 2. And it now wants you to find p of -2. Oh, find. Forgot the word find. So see, again, this is now, instead of P3, it's asking for P -2. So it's going to tell you what it wants you to look for. Perfect. A couple things to note too when you're plugging in. Again, notice that these exponents are outside the parentheses. Make sure if you're typing in the calculator that it's also outside of the parentheses. All right, so if you do this by hand, what is -2 cubed? Well, multiplied by 4 will give you -2. So what would be -2 to the third power? The exponents goes outside the parentheses. Yes, sir. Very good. -2 squared. Four. What's up? Is it the negatives with your phone? Oh, okay. Yeah, they've all kind of gone ahead, which is fine with me. I'm good. What? Looked like a bad 2, look like a C earlier. All right, so now I can multiply. So now what was 4 times -8? There it is. And then 2 times 4, -8, because that sign will go with it, times -2, +16, plus 2. -32 plus 8. -24 plus 16. -8. And then the last part, what's -8 plus 2? -6. And again, that's if you're doing it by hand. But again, at any point, you could have plugged it into the calculator and it would have gave you -6. The plus 8 right here, 2 times 4. So this is a -8 times a -2. So 2 negatives would make a positive, and then 8 times 2 is 16. Negative. Negative. Mm-hmm. Mm-hmm. So it's basically like you owed someone $32 and you just kind of chipped away at it and you still owe $6 still. All right, let's try another one. All right, so we have 8y cubed minus 9y plus 22. And I want you to go find P of 2. I'll give you a chance to do this on your own. Yes. Oh, I love it. What are the numbers? I got a 68, I got an 84, 68. I got 5. All right, let's see. Love it. Nine times 2 is 18, yes. Oh, happens all the time. Yeah. That's kind of what I was kind of doing here too. Like I would do the exponents of each one of them. I could have multiplied at this point, but I wanted to do it all together the next step. So I kept it and then I came down, multiplied it, and then just started adding from left to right. Because you get 2 cubed is what? 2 cubed would have been what? 8. And then 8 times 8 would be 64. So that's how it's 64. Bless you. And then 9 times or negative 9 times 2 would be negative 18. And now 64 minus 18 would be, it is 64 minus 18. I mean, you could call it plus a negative if you would like, but it's technically a minus. 46. And then 46 plus 22, 68. All right. Now that y'all got that caught on, let's throw a huge wrench into it. This is the last question in this section. So it gives you a function like this towards the end of your homework. F of x equals 8x minus 27. And at this point, you might have hit that 80 and be like, all right, I'm good. I'm gonna walk away from this one. But then it's going to ask, huh? It does. It does. You never know what's going to be on that test. And then it's going to say, hey, find f of 3a minus 1. So instead of just a number, it's asking you to plug in a whole nether equation into a, oh my goodness. Go away. There. It's basically asking you to plug in a whole nother equation into an equation. Mm-hmm. Well, let's plug it in. That's what it looks like. So the x is still being replaced with that function. So I'm still going to replace that x in parentheses with this function itself. So that becomes an 8 parentheses 3a minus 1 close parentheses minus 27. So before I move on any further, are we good there? So I kept it kind of the same pattern as I did with the numbers. There's just a function there. So now I'm going to use my simplifying rules that I've used up to this point, and you're correct. To get rid of parentheses, I need to distribute. So 8 times 3a would be, very good. And then a times negative 1 would be, no, you're good. Now I can combine like terms. What is negative 8 minus 27? There you go. And that would be the answer.
I had one of our homework where you had to figure out what that is.
Oh, you have to name it?
Like 3 days. It was yeah. It was the last question.
It said what? It gave you 3 days to do the problem? So it's like a word problem? Oh. Oh, so T yeah, so 48. I gotcha. So you would you basically had to calculate your own T and then plug it in. I gotcha. Yeah. Yeah. All right, so what we'll do is take a little 5-minute break, and then we will begin 12